Hey there and welcome. Today we're going to solve a mystery you might have actually seen happen in your own house. We're calling it the chilly case of the deflating beach ball. Let's dive right in. All right, so here's the central question. Imagine this. You take a perfectly pumped up beach ball and you stick it in the freezer for, say, 30 minutes. What happens? I mean, it sounds super simple, right? But the science behind the answer is actually pretty amazing. Okay, to figure this out, we've got to go microscopic. We need to look inside that beach ball and meet the tiny, invisible culprits that are actually doing all the work to keep it inflated. I'm talking about gas particles. And this is our first big clue: gas pressure. It sounds kind of technical, but it's not some weird abstract idea. It's literally just a physical thing happening. It's the force created by trillions of tiny gas particles all smacking against the inside walls of their container. In our case, that container is the beach ball. You gotta picture these particles as being in constant, chaotic motion. They're spread way out, which is why you can squish something filled with gas, but they're also zipping around really, really fast in totally random straight lines, just bouncing off each other, and this is the important part, smashing into the walls of the container. That constant bombardment, that's the pressure. Okay, so if pressure is all about these collisions, it stands to reason we can change the pressure by changing the collisions, right? Well, it turns out there are basically three main rules for doing just that. Three ways you can mess with the force inside any container. Let's get into them. So, rule number one, what do you think happens if you just add more particles? The best example is pumping air into a bike tire. Every time you push that pump, you're literally cramming more and more air particles into the exact same space. Yeah, it's pretty intuitive when you think about it. More particles jammed in there means it's more crowded, like a traffic jam. That means way more collisions with the inside of the tire. And what do more collisions mean? You got it, higher pressure. And that's exactly why the tire gets hard.
All right, let's move on to rule number two. What if we don't change the number of particles, but we make their house smaller? I mean, we decrease the volume. Picture someone trying to sit on and squash one of those giant physio balls.
Exactly. You're forcing the same number of particles into a much tinier space. So now they don't have to travel as far to hit a wall. It means they're going to hit the walls way, way more often. The result? You guessed it, higher pressure. Okay, and now we come to the final rule. And listen up, because this is the one. This is the key to solving our whole beach ball mystery. What happens when you bring temperature into the mix? See, temperature is really just a measure of energy. So when you heat up a gas, you're basically giving all those little particles a shot of espresso. They get a huge energy boost, start flying around way faster, and they smash into the walls harder and more often. But when you cool a gas down, you're doing the opposite. You're draining their energy. They get sluggish and slow down, and their collisions become all weak and less frequent. All right, so we've met our culprits, the particles. We know the three rules of pressure. I think we have everything we need. It's time to put it all together and finally solve this thing. So here's the breakdown step by step. Our scientific hypothesis is this. After a half hour in the freezer, the ball is going to look and feel deflated. And the reason is that the pressure inside has dropped. But why did the pressure drop? Because those super cold gas particles have lost their energy. They're moving slower, so they're hitting the inside walls of the beach ball less often and with a lot less force. And that's it. Case solved. And you know, this is what science is all about. What we just did, that's called forming a hypothesis. It's not just a wild guess, it's an educated guess based on the rules we just learned. And the coolest part about a hypothesis, you can actually go and test it to see if you're right. Which brings me to my next point. Don't just believe me. It's your turn now. Go become a scientist in your own kitchen and test this thing out for real. It's super easy. All you need is a small beach ball or even just an empty plastic bottle with the cap screwed on tight. First, give it a squeeze so you know how firm it feels. Then, stick it in the freezer for about half an hour. When you pull it out, squeeze it again. I guarantee it's going to feel softer. The pressure has dropped. And hey, if you want a little bonus science, take that cold ball and float it in a sink of warm water. You'll actually feel it get firm again as those particles wake up and start moving. So there you have it. We've seen exactly how temperature and gas pressure are linked. And I want to leave you with a final question to chew on. If a freezer can do this to a beach ball, what do you think happens to other things when it gets cold outside in the winter? You know, things like your car tires? It's something to think about next time the temperature drops. Thanks for hanging out with me.